Hello, this video we will be doing a small project here with JavaScript React. This tutorial will show programming with classes. It will even show programming recursion. We'll cover a little bit of recursion. Of course, we will cover some JavaScript front-end React, such as how to start up your React project and how to get some front-end interaction. So this project will be, and I'll write some notation here, is this React project. What we're going to do is I actually forgot how to make a notation here. Yeah, what we're going to do is going to create a couple classes, a class of person and a class of users. And what we're going to do is we're going to put in these classes a person like username string, and we'll have an ID string, and the ID string will be 9 digits, and we'll make 9 random digits. So we'll use like the math.random class to make 9-digit IDs. Our app will also be able to prevent duplicate usernames, and since the IDs will be such random, and we're going to create an algorithm for it, because the IDs will be so random, we're not going to really have the IDs as the, you could say, primary key in our little database here, but we'll use the username strings. Besides that, I think we'll get started with coding this, and I think the first thing we'll do is just kind of quickly go over some of the back-end boilerplate we'll have. Let me format this a little bit. So the first thing we'll do is we'll create a class of person. This is how you can create a class in JavaScript, and we'll give a constructor, and the constructor will be a username, and we'll of course do the obligatory this dot username will be a username, and we'll also throw in a dot trim in there. So so when somebody types in a username, let's say the username is like dog, let's say they leave a space, we won't be dealing with spaces in our objects, so we're going to trim it. And the next thing we'll do is we'll create our class of users, and we'll say constructor, no args constructor. It's a no args constructor because, as you'll see when you start up the app, the first class it will instantiate will be users, and we're going to have an array of users, and our person class will just simply be the username, and we're going to do more with that. Okay, so we're going to go ahead and show some memoization. So of course if we want to just instantiate a person, we could do something like let person equals new person, right? Let's say we give it a name, right? This is how we can instantiate a person, especially considering our rules here where this dot username equals username. This might be confusing, we're using person here. You just do u person, like username person. But when we have a person, I think one thing that we have to deal with is that, yeah, so a person is also going to need an ID, right? But our constructor only has a username in here. The way things will work is each person is going to need an ID. So what we'll do is, so in the person class, we're going to do a set ID. And we're going to set ID by passing in an ID number. And then this dot ID will equal ID. Okay, so what we'll have is we'll have like a front page where we'll have a person, the front page of website will have a person slash user, right? A person or user, whatever you want to call it, will type in their name, right? Such as Bob, such as Tom. And so when they type in their name, what we're going to do is we're going to have a method, we'll create it later, where that name will be checked inside this array here of the user array to see if that's a good username. And we're going to have a built ID number. And after the username, it passes the check of whether or not it's duplicate, then the object, then we're going to do more stuff. We'll show more stuff later with that. So we have this uPerson here. We're going to do uPerson dot set ID, right? We have our set ID method we created. The problem though is what we need a ID number. And right now we don't have a method to build an ID number. We want 9-digit ID number, totally random. So of course we want random numbers. We don't want people being able to easily guess someone's ID number, and we don't trust a human being to just come up with a random ID on their own. So what we'll do is we'll create a function called buildR, and this is where I'm going to show you memoization, right? I'm going to show you some data structure algorithms technique. And one thing to note is that our ID, although we're coming up with an ID number, this function will return an ID string. So we're going to put inside the user class an array of strings. So yeah, we want our user class to have an array of users with strings. Okay, so right now this function here, we need to build a 9-digit random ID number. We're going to have an empty array here to help us out. And then we're going to create a for loop to help generate our 9-digit ID number. 0, let's say I is less than 9. I++, and there's many ways you can generate a random ID number. We're just going to do it this way. So from 0 up to I is less than 9, from like 0 to 8, for that many times, we're going to r.push. Okay, we're going to push a number up into this array here. Math.floor math.random times, and we can get really creative with this stuff. There's many different ways again. So we're going to push into the array a random number between 0 and 21. You could say exclusive. I'm just going to have a reminder that we're going to return a string, okay? We're going to return a string. We haven't yet defined what the string is. But our let string will equal r.join, and .join is a method to take an array of stuff. Generally you do it with like an array of numbers, but it's a way to just take an array and just join it and make it a string. Okay, this is similar to saying toString on an object. It's a similar idea. It's an array to string technique. And since we want a a 9-digit like string, right? String dot length. Now this might be confusing, but we're going to say if it does not equal 9. This is where we're going to do the memo stuff. Memo.push dot substring 0 and 3. So we're going to push a substring between of a substring that is 3 characters long. Okay. So you see here from 0 up to 8, we're pushing a random number between 0 and 21 exclusive. And so if you could imagine that, we might get a number like this. We might get another number like number like that. We might get a number like 11. We might get a number like 4. We might get a number like 18 or 10 or 0. Right, we might get any of these numbers. Let's just throw another one in there, or 7, right? And if we were to count up how many like characters we have here, if we were to join it like we did here to a string, we might have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We're gonna have more than 9. Okay, so that's what this method here is doing. If we get a random number slash string of integers that's more than 9, which is very likely we'll have, we're just going to pull out the first 3, right? And we're going to pull out the first 3 and push it into our memo. And this is an important technique here with JavaScript and algorithms in general, which is memoization. So in JavaScript, you can create a default parameter here. Okay, so when we finally call this method build array, we're not going to pass any arguments in. But JavaScript, you can just define a default, which would be memo here. And so this function here is not particularly intensive. I don't think you necessarily even have to do memoization or recursion, but we'll do it anyway just to show it how it works. But when you're doing recursion with memoization, it's good to just use this technique where you pass in a default array here, and we're going to use that array. We're actually using a couple arrays here. So we're likely going to have a 3-char substring getting pushed into this array here. And it's interesting that every time this function swings back around, it's going to have a nice new clear array to deal with. But anyway, in the return statement, and this is the recursive part of this function, if string.length equals 9, we're going to return the string, right? So if our string.length equals 9, then we will have successfully created an ID number that is 9 digits long, right? But here it looks like we're very likely to just have a lot of strings that are more than 9 long, and so then that's why we're going to use our memo here. Else, we're going to call the recursive function build our memo with the memo. Okay, with the string in our memo, and it's going to swing back around, and then this is where we're going to have to stop our function, come up with a way to stop our function. So if memo.length equals 3, we're going to return memo.join, right? Because we want a string. Okay, so we're pushing up into our memo substrings that are 3 long. And what's 3 times 3? 9, right? So this is how we're going to get a substring that is just 9 like characters long. And so now we have our function. You could call it a helper function. Generally, you associate helper functions with being inside of classes, but this function we created here will help us build an ID number, which will be very useful for us. And so now when we construct a person and we want to set the ID, now we can call this function build our, and we don't have to pass any arguments in there. So yeah, so once a person calls this set ID, now we'll have a person with a username and an ID number. Yeah, since we've built a person, we need to add it to users, right? We want to put our person in our user array. We could instantiate it up here if we wanted to. We could say user, yeah, I don't know, user test equals new user. And in order to, yeah, users is no args constructor, right? I don't even think you need the let keyword here, to be honest. It's going to give you some advice here, but I think you can get away with it without using the let keyword. Let's just create a couple more. Let's create another person. Or let's run this function. See what happens if we run this. What we got so far. Okay, we ran it. So there you go. We have a username of Tom, and that's his ID. For some reason, I kind of got this weird anxiety that when I called this build array method, it would not. I wasn't sure the positioning on where I have to have my function calls here, but yeah, that works. So we console.log the user here. All right, try that again. Okay, cool. So you see, this is okay. So we have two persons, and they both have the same username, Tom, and they of course have different ID numbers because these ID numbers are totally random. But we don't really want to have duplicate, right? We don't want to have duplicate usernames in our little program here. However, we also would like to persist or put new persons into our users array. So in order to put them into the users object class here, we're going to have to check that there aren't duplicates. So we could easily create a method here simply to just add persons into the user class. We could call this function add users, and when we add users, we're going to pass in, right, a person, right? Now what we could do is we could say, we could create a field, right, a field property here, right? We could do this, right? Let's try to run that again. We want to print utest. Print that again. Okay, so now we see that so now we see that our user class has a person in there. Dot push person. So let's see if that builds for us an array in the users class. Users of 1. Okay, so it's a users of. Okay, well the point is when we add users into our person class, we don't want to have duplicates. So what we're going to do is we're going to create a function to do just that. We're still going to use this line of code here, but we're going to put stuff above just to check. If this .users.every, and there's this function called every, where the every function, and it says here, determines whether all the members of an array satisfy a specified test. So we can go through, like, let's say this array here, and check every item, and it returns everything is a boolean, right? It returns true or false for each item. Item.username does not equal person.username. Then we're gonna put this up here. And we just return the person, right? Okay, the way our program is going to work though is that every time a user signs up on the front page, it's going to create an instance of this class where it's just going to have one username in there. And so what this function does for the users class is it will check every element in this array here, and as long as nothing matches in this element with this field in the person class, then it will pass the test and push it into the users. Else it's just going to spit the user object back, and we won't be able to use that person. So now that we have a function to add users, let's go ahead and test how this will work. And I had to clean up this block here. I had redundant stuff here. I had this dot. I had redundant stuff. Had to delete that just to fix it again. Okay, so our user class has one person in there, Tom, and that should show that our code is working, because even though we instantiated 2 people of Tom, Tom only persisted 1 time, and that's because Tom is a duplicate name. So let's test this with a different name here, Mark, right? And let's see how that works. There we go, our user class has 2 different people now, Tom and Mark. And so that's how we know this helper function here is working correctly, this add users. This prevents duplicates from getting in there. And so now we're going to add an extra feature. Now what we're going to do is we're going to show how to make a sorted array. So you can take this, like, let's say our 9-digit string here, right? And let's say we wanted to make that sorted. So instead of having like 1 4 1 4 1 7, right? Instead we wanted this sorted, which in the world of programming means sorted from in ascending order, right? So 0 1 4 5 7, right? And this is going to get more advanced where we're going to have, you'll see, we'll have different conditions here for, right? This is ascending order. Now I'm just doing this just to kind of show how these higher order functions work in JavaScript, even with recursion and memoization. So yeah, this React app is going to have this feature where a user enters their username, they get a random ID number, and then they're going to be able to have like a hint. So like their random ID number is 9 digits long, and they're going to be able to get a hint of like what are the last 3 numbers in that ID. What are the three biggest numbers in that ID, right? And so that could be like their password / like ID hint. Okay, so this is all just like algorithms and sorting and stuff like that. Okay, so let's test getting the first element in our array, getting the first person in our array, and we're going to take this field, this ID field here, and we're going to call the dot split on it. So we're going to convert a string to an array. And then in order to start doing a sorting thing, because in JavaScript you can't just have like an array of like, let's say, numbers here, numbers represented as like strings, right? You can't just do this, right? And then just like say like dot sort, right? Because these are strings and it's not really going to sort them. I think if you did dot sort on something like this, you would just get the same array back, because it's gonna, when you're sorting strings, it sorts it by length, and each of these strings are like the same length. And I think if you even if you have an array of numbers, let's say if you have an array of numbers like this, it's not reliable to do the dot sort on it, because again, it's going to take this number 76, and let's say we had another number like 22, like, or 33. Let's say we have these two numbers, 33 and 76. It's possible that it's going to put 76 in this position and 33 to the right of it. It's not going to sort it correctly, because JavaScript is going to convert these to strings and then evaluate the length of the strings. And so 76 as a string will be the similar length to 33. So it's not always so simple to just use this dot sort on a list or array. You sometimes have to go the extra mile. We're going to have another variable here called let array of ints. This will equal to this new array dot map. We're going to map this we're going to map the array created from this, and we're going to, for each char here, we're going to make it an integer, an actual number. We can use our arrow function, just simply parse int for each item. So .log. Wow, it's not going to help me pre-type this stuff out. What happens if we console log here? Let's see how far we're at. Okay. So for the first, I'm going to clear this. Let's just run it again. Okay, so for Tom, with his ID number here, it successfully made this into an array of numbers. And remember, we didn't get this array here, because here we're just calling it on the first element. Now, in order to successfully sort this array, because what we want, see this array, we want to sort it. So we want like 1, 1, 2. You get the idea. From 1 to 8, we want this sorted. So we're going to have to create a function for that. Let's function new array. Now this is where it's going to get complicated. Memoization. I'm just going to quickly just blow through this a little bit. Some advanced stuff here. First higher order function I'll show you is the reduce. And what reduce does is it goes through an array and it reduces it down to like a number. So reduce, it's not letting me highlight this. I just had it, but yeah, reduce will go through like an array. Let's say this array up here, and it can do something like reduce it down to one number, such as 66. It can go through this array and give you like what the highest number in that array is. It could go through this array and return the lowest number. And it could like go through this array and add this number 2 to 2. Oops, I messed that up. It could add 222 to 3. It could add this number to that. So it can go through each item and just perform the same repetitive function on each mathematical expression and reduce this array to, like, let's say the sum of all these numbers. So that's what reduce does, and you're going to have to pass into it the first number, where it starts, and then the next, where it starts, and then the next. Use the arrow here. And you have to tell it where to start from, I think. So we're going to start from R at 0. We're going to start at the first element in the array. We're going to go through this array and find the highest number, right? If max, right? Let's say we start from here, max, this max variable here, parameter, whatever you want to call it. We're checking the truthiness of the next, each next to the element right before it. We're checking max, the number we're at, to the element before it first. Return max, right? So if the element we're at is bigger than the one before it, we're going to return the number we're at. Else, or else we'll just return the first number. So this is going to help us reduce. And let's just say, and this is all, the reduced number is stored in this variable, a. And then let's just return a. Console log this. Hey. So he ran this test again. Tom, this is his ID number. This is the array of ints from that ID string number. And our reducer function says 5 is the biggest number in this array, which is correct. So far our function is good. It's returning the biggest number. Although what we want is we want the user to get like three numbers that represent the three largest numbers in this array. And so far we only have it returning one large number. Let's just do that for now. And we're going to create this parameter called length. So length is going to be the number of numbers we want to come back, right? So we want the user to get 3 numbers back. So we're going to specify that we want 3 numbers back from this function. We're going to update our return statement because we actually want to return, this is confusing, but we're going to return a recursive function here. And this will make sense in a minute. Okay, so since we have a here, which is the reduced number, what we want to do is every time we get the largest number in this array, we want to save it. We'll do r.forEach here. For each item. Item is in A. Memo. Now we're going to use our memo. Unshift is a method where you push items into an array, but in front of the last item. So this is how you. That's one way to reverse a list. /array. Elements to insert at the start of the array, right? So this array here that we're passing into this function here, we're going to check. A lot of times we have these duplicate numbers. So what we want to do is we're going to find the largest number in the array, but then for each duplicate of that number, now this array doesn't have duplicates of 5, but let's say it did. I mean 1, there's duplicates. So for each duplicate of a number that comes from our reducer, for each duplicate we want to push that into the memo up here. And you see how we're returning this res here, which looks different than here. That might be confusing. Our recursive function is going to return a new array, which we're going to call res. r.filter, and we're going to filter out every item that is not equivalent to our reducer. E does not equal A. Right, so this A, remember, is the reduced number. This is the largest number in the array. And so for each, we're going to go through the array we pass in, and every number that does not equal our reducer, this filter number will make a new array for us. Filter method, it goes through an array and it helps to return a new array where each element in the array passed or didn't pass a certain condition. So now we have a recursive function, and our length will be decremented 1, right? Because remember, we want to return a new array of length 3. And so we tell it we want a length of 3, and so each time it recurses, that length will get decremented until we are at 0, right? And when we hit 0, that's when we'll be ready to exit this function. So we need to create a statement for that. So if length equals 0, I think we could also do, if we wanted to, we could do not length. It's the same thing. But if length equals 0, if flag, now this is confusing. This is our flag here, right? If flag, we're going to return a set, or we're going to have this variable here called return set. This is going to help us out, and it's going to make more sense. else if not flag. If our flag is false, which I think our flag is false right now. Yeah, it's falsy. Okay, so remember our memo contains all the numbers that come from our reducer in ascending order. So our memo is what we're returning from this function. And again, that is an array. Our memo is an array with numbers in ascending order, and our array is going to be of a length 3. 3 elements will be in that array, but this is the caveat part. If our flag is set to true, okay? If our flag is truthy, which right now it's falsy, but if we were to, like, let's say make this true. Okay, so if we were to make this true and our flag would be true, then we're going to return the 3 largest elements without duplicates. If we take this array, what we're going to return is we're going to return 5, 3, and 2. Let's say this array had like 2 3s and 2 2s. Our function is still going to only return 5, 2, and 3. Now, if our flag was false, falsy, right? If not flag, if falsy, we're going to return the full memo. We're going to return the 3 largest elements and all their duplicates. So maybe this does or does not make sense. But this is recursion though, and this is why it gets a little confusing. Remember the set class, it helps. A set, what you do is in the constructor for a set, you pass in a list, or I should say an array, and it takes that array and it returns a set, which is a new array without duplicates. And so when you have, like, let's say an array such as like this one up here, and if you were to return a set of this, you would get a set of like 66 and 10 and 5 and 4 and 3 and 222, and the length of that set, right, would be the total number of unique elements, right? So if we created a set from this, the length of the set would be like, let's say 22, 3, and 4, right? That's 3, 4, 5, 6. The length of this set would be 6, and that is going to help us out with knowing, with kind of dealing with how to build a function here. Okay, I wonder if I'm actually ready to run this. I think this is correct. Let's see what happens if we run it. Okay, I ran. And remember, we had this set to truthy, right? Let's just clear it and run it again. Okay, so we have 2 users. Tom has a user ID up here. And if we look at this really quickly, the 3 largest numbers in this, what we could call an array up here, are 9, 6, and 8. And look at that, our function returns the 3 largest elements, 6, 8, and 9. The 3 largest elements in ascending order. And our function is so good, it's really powerful, right? It took this array here and it ordered it and gave us the 3 largest elements. Now let's test our falsy flag. Try to run it again. Yeah, so this is working. Okay, so our array up here, the 3 largest are 7, 8, and 9, right? And we got an array back. We didn't get the set back, which means it's working right. I'm going to really show you when it really, we need a good example of it running a certain way. There we go, that's what we're looking for. This array down here, right? So when we set the falsy flag, it's going to give us the 3 largest elements and all their duplicates. The 3 largest elements here would be 6, 3, and 2, and these do have duplicates, and our method will return the duplicates if we have the falsy flag. We'll run that again just to show. We have 8, 5, and 2 here, returns that. But if we just keep running it until we run into a good example. Okay, so yeah, we had this interesting random number here of 7, 8, and 1, right? And so what it did is it actually returned the whole array in ascending order. 3 of them, 3 unique values, but that's just kind of the luck of the draw here. This is another good example. 9, 5, 8 are the 3 largest numbers, and it gives us all its duplicates as well. So that's the falsy flag. And the truthy flag, again, will return a set. Right? It will just return without the duplicates the 3 largest elements. I think the most important thing to keep in mind when you're trying to make recursive functions is how to properly use the memo. Remember, it helps to just put a default memo up here in the parameter, and then remember when you're calling the recursive function down here, you have to remember to just put memo in there as well. You have to pass it in, so it's kind of counterintuitive, and you need some sort of concept of base case when you're doing recursive functions. So you need some condition up here where if true, it's going to help exit your function. Otherwise, recursive functions are liable to break, to Stack Overflow. So you need something to stop it, and it's also just practically useful. Like in our case, we purposefully want to stop our function because we only want 3 evaluations happening. So up here we stopped it when length equals 0, and our evaluation started at 3, and then we decremented 1 at a time until we're at 0, and then we were ready to exit our program. And I think this just about wraps up this back-end coding. And again, this coding handles a person entering a username and then the program generating a random ID for them, and then that person object is pushed into the user class, and every time a person is pushed into the user, it checks if that person username is not already in the object, and as long as it's a unique username, person name, it will go into the class object here of users. And in our React app, as soon as a person is successfully entered into users, then the app will render a response back to the user. The rendered response back to the user will include the name of the username plus a hint, what I call a hint, which is 3 of the largest numbers in their ID. So this will make more sense when we actually create the app. To create the React app, you type in npx create React dash app, and you give it a name. Recurse video. You can't have uppercases. Can't have the uppercases in React. It's going to throw you an error. But this is the command to create a React app. You go to your directory. It could be your documents folder or your desktop folder. And when you enter this name of the project here, it's going to create a project folder for you. And you just run that. It's going to take a while. Okay, so React created our app. And in order to add the app you created, cd into that project you just made, and you do code dash add period, and it'll immediately throw it into your workspace here. This is what your React app looks like. Package.json is important. I like the git ignore. It's very standard to have your node modules in your git ignore, because this node modules folder is huge. It's like, I don't know, 60 megabytes or something. Don't need all these icons here and stuff, but we can play around with that later to kind of make the site look better. Could get rid of some of these test folders too. Could just delete that. Won't be doing a test. README folder. Okay, so let's go ahead and start building the actual app.js. And we're going to import some of the backend code we have here from our app.js over here. And this will go into the top of our app.js. Import that. Person object, user object. And we're going to have things like use state and use effect. And I think the first good thing is to make kind of our front page, kind of build the UI for our front page here. So to do that, I'm going to actually copy and paste some boilerplate I have. So we're going to have a form, and the label will be username, and we're going to have a function called handle submit. So when somebody types in the stuff and they click submit, we're going to have a function to handle that submit. So the next thing, of course, what we need is we need a function to handle submit. On our event, that's a parameter. It's deprecated for now, we'll fix that. Event.prevent default, kind of a boilerplate thing to do with React. And this is some regex we're making here. This is a regex. This is kind of advanced stuff, but I found this useful just to make our app a little bit cleaner. So this is going to exclude white spaces of more than 2. So if, let's say, somebody were to type in, let's say somebody typed in a username like this, right? Let's say then they said their name was like Bob space Greg. Let's say they said their name was Bob Greg. This program's not going to allow 2 spaces, right? It's going to allow 1 space, but not 2 spaces. It'll also help deal with somebody who, like, let's say, creates a space at the beginning. And it's also going to prevent people from entering digits. So you can't enter digits into the username field. We want your username/name to look like a real name. And if the person does not pass, okay, so if it doesn't match, then you'll enter into basically the rest of the program, right? So this check input sees if what the user enters matches this, and they probably won't match. And as long as they have a good username, we're going to enter the program here, and we're going to give it an alert. Template literal, you entered the name and whatever username they entered. Now this username we don't really have, like, right? We didn't pass it into the parameter, so where are we getting the username from? And that's where the use state comes in. But yeah, to use state in React, you have to import use state from React, right? And it's telling us we haven't used it yet, but we're going to start using it down here. Username, set name, so it's going to use a state of blank. That's our first state, it's just blank. We're going to go ahead and create the use effect or the use state for our user class or user type object. Similar story. We use a blankety blank state. Okay, so if we have a good username in the system, we're going to give them an alert telling them you entered a good username. Else, because it's possible somebody enters a bad username, we're going to return. Just simply return, and basically the app, the website, the web page is basically just not going to do anything. It's just going to stare at you. And then we're going to bring in our person object. I'm sure I don't think I even have to use that let keyword. I don't know why I keep using it. And before we were typing in literally like the word Tom or Mike, but here we can pass in the username, right? So we're going to pass in the username, which is a string, and then we're going to go ahead and use our set ID, right? Because each as soon as somebody puts a username string into the class, we're going to also put a random ID number in there. And you see we don't really have this boilerplate pasted in yet, and we're going to have to do that. I think I'm going to make the rest of I'm going to continue on this path here where I just keep typing in the React, the front end code here. I am getting a little ahead of myself, but there's really no efficient way of doing this on a streaming. And we're going to give an alert here. Username is already taken. Now I'm going to return. Okay, what did I just do here? Okay, remember we had this add user function? Right, when we add a user, and let's say there's a duplicate, let's say that username has already been used, our function just simply returns the person, right? And so down here, if the result of calling that add user function returns a person, right, equals person, that's when we know that there's a duplicate, and the program's going to say, hey, that username is already taken, and it's going to return. And like earlier, whenever we have a function that just gives a blank return here, it just generally means like the program is just not going to do anything. So this is our boilerplate, right? Our function to build a user ID, and we have our function down here to create our hint, our user ID hint number. And I might as well just, I guess, just copy and paste all this stuff in. Copy and paste. So that's a lot of our boilerplate. We're going to console log some stuff when we kind of render this on the front end. We're going to bring in our flag. This is our flag for if somebody's going to print out a if somebody's going to bring back a hint that is a long string of numbers or a short string of numbers. And that's down here. That's our boilerplate is checked. That's our checkbox. So we have it. We're going to have a checkbox in this front end. We're going to use our use state. Array events. We want 3, and we do want trim. We want our flag variable in there. And with React, we're going to have to deal with strings here. We're going to join that array. Person, we're going to display the person.username they entered. We're going to send that back to them. Okay, so if we successfully have a user, if a user is successfully created, we want to render it. And that's where we can put JavaScript inside this kind of JSX setup here with these brackets. So if we have a user, we're going to return it. We're going to render it inside a div with an h4. I have to fix some code here. I'm actually just going to copy and paste this in just to expedite things a little bit here. Now we have extra div tags. We don't need this many div tags, do we? But yeah, this right here, if you look here on change, this is an important tag to have. So when that submit button is clicked, it's going to trigger that set name, and it's going to target the value, what was entered into the field on the front end. So if we go back up here, up our code, I'm getting disoriented here. But yeah, that event, whatever was punched into the, or I should say, when that event was triggered, that is passed in. That's a parameter. And I have an error here, const trim. And I thought I had used that word. Oh, because I'm declaring it twice here. Const trim is checked. Yeah, I think I'm not supposed to use this one here. We don't need this. It says it's declared, but it's not used, so let's fix that. Well, the reason buildar is not being called is because I spelt it wrong. It's always those little weird things. Yeah, for some reason in JavaScript, I had a hard time, or this React framework, I had a hard time making this new set object work. So there's a long way we can hard code a set. So like, how would we go about having an array? Remember, our memo object is an array, so how could we take like memo? And so the way we can create a set is we can use our for each method. We're going to go through the memo array and push into this new array here, into our set array. So memo.forEach item so if this empty array here, as long as this empty array does not include each item in the memo, we're going to push it. Still having errors. uTest is not defined. I thought I got rid of uTest. Haven't gotten rid of uTest. Let's get rid of that uTest. That makes more sense. I spelled it wrong. To fix this. Yeah, I had to fix that. I was returning the wrong one. We still have a couple more errors to handle. Is checked is not defined. Handle on change is not defined. Let's check the handle on change. I forgot what that even does. Oh, right, we need to make our handle on change. So this is for the checkbox. Right, I forgot about that. That was the thing I was thinking of earlier. Default will be false. Handle on change. It's an anonymous function. And we're going to set the state of that. To false. So we finally have it rendered. Now let me just, since I'm getting neurotic here. So the only errors we have really are just these ESLint, these formatting things here. I should fix this error here. This does not equal. Let's fix that. Find the next one. If it does not equal. Oops, I messed that one up. Okay, cool. Let's bring up our terminal. Well, I thought is checked is defined. Let's refresh this. Cool. So it looks clean so far. Alright, so let's submit 55Tom. 55Tom should be invalid, should give us a hard time. And I hit submit here, and it's not doing it, which is good. It means it's working. If we give a space and we type some stuff in and we submit again, so far that's working good. So let's enter a real name. Let's say we enter the name Jerry. We get our pop-up. You enter Jerry, and immediately it console logs our person. It console log Jerry, and it also even rendered. And we don't have the short hint text checkbox ticked, right? So because we don't have short hint ticked, we're going to get the long response here. I could fix the formatting here a little bit. I put the formatting. I totally forgot, man. Let's put a space there. Let's try that again. Mike. There you go. It gave us a space there. We try to enter Mike again. You see, we immediately get that pop-up saying Mike is already taken. Enter the name of Sarah. Now I have Mike and Sarah in there. Try Timothy. There you go. That's right. Let's try our long hint. Okay. I don't think I really changed anything. I changed the console log because now we're just console logging the last element in the array. Okay, and then let's tick our short hint. Four, 8, 9. Yeah, our short hint's working now. Okay, so there we go. It is working. Our short hint and long hint is Bobby's already taken. Okay, that's working still. We want our short hint. Yeah. It's doing a good job of returning the short hint. Let's flip it back to long hint. Yeah, our long hint's working. Yeah, so this is good. So I'm going to put this code up on GitHub. This is a good project to practice your data structures and algorithms, and also to get comfortable starting up React apps. I actually learned this a couple days ago, but when you create a React app, it immediately, and it's a Git repository. I might have known that. I don't know if I forgot I knew that, but one git ignore trick I like to use is use the star button. So let's say you have all kinds of files and folders, and you just don't really want to go through the process of accurately telling Git which ones to ignore. There's many different techniques to configuring your git ignore, but one good one is to just use a star here. So this will ignore everything, every file, every folder in your thing. And then down here, you can enter star. I don't know why, what just happened. But yeah, you could put a star here to ignore everything. And then do an exclamation mark to do except, like let's say your src folder. So I could do star, ignore everything except, let's say I wanted to put on GitHub this src folder. So that's just something to play around with. Anyway, yeah, check out the source code on GitHub, and happy coding.